Greetings. In this first in a series of videos on the subject of construction cost estimating, I am going to review some of the most basic concepts that you need to keep in mind as we progress into this very complicated but exciting, interesting, and just a critical skill that for any construction company, somebody has to do it. However big or small the company, it's a very, very important niche. Cost estimating makes or breaks companies. Okay, so the subject of construction calculators, not really necessary. We typically will be translating dimensions from plans into decimals, not into feet and inches. Or not into fractions. So we're going to be moving into decimals. So this really isn't necessary. Just a standard calculator and or Excel, both of which we'll be using, will suffice. But there are free downloads for construction calculators if somebody wants to use one, wants to look at things in fractions. But again, we're going to be working with decimals primarily. So what is a cost estimate? It is an approximation of the cost of a program, project, or operation. So an approximation. Don't know what the final cost of anything is until it is complete. Cost estimates come prior to the project, so it's all it could be is an approximation. The quantity takeoff, or the QTO, is a detailed measurement of the materials and labor needed to complete the project. All right, so this does not involve dollars. This is just trying to determine the amount of materials, counting the sticks and the bricks, as I say. They're developed by the estimator during the pre-construction phase, so the construction company gets a set of plans from the architect, and with those plans they have to again count all the sticks and the bricks before they put their bid out. So that happens pre-construction or pre-con. These measurements are used to format a bid on the scope of construction. Measurements are used to format a bid, yes. So the bid is the final product that the construction company is coming up with to attempt to get the job. Estimators review drawings and specifications to find out these quantities, yes. So that's what they get from the architect again, and the specifications come along with the drawings, and those are that's the written portion of the project manual or the construction documents as a whole. Okay. Quantity cost estimating requires math. Yes, it does. Again, we're going to be taking dimensions off of plans, and we will be turning them into decimals and inserting them into Excel. That's going to be pretty much the most fundamental path that we'll be taking there. Understanding translating two-dimensional construction drawings into three-dimensional buildings. Yes, so you have to be able to look at construction drawings and be able to visualize the finished product. So that takes experience and study. Understanding the construction sequence, also very important. So the architect and the design team do not talk. This belongs to the construction manager. That's what I'll say. The design team should consider the construction sequence, especially in complicated projects. A house, they wouldn't. There's no reason to. This is the job of the CM, the construction manager, and it takes organization. Yes, you have to be very thorough, very careful, crossing T's, dotting I's. Otherwise, you're overbidding, or even worse, underbidding. Okay. All right. So this complicated looking chart is an inch to foot conversion table. All right, so we don't care about all of we only care about these 12 right up here, the first 12 inches. So 12 inches equals 1 foot. 6 inches equals a half of a foot. Okay, and this sometimes trips up people who are students or people who are just starting to tackle this type of a process. So sometimes I see people who want to turn 6 inches into 0.6, but that's not the case, right? So there are 12 inches and 6 inches equals a half a foot. So that's how that gets translated. Now let me bring up a calculator here, actually. Okay, and the way we come up with that number, so 6 inches equals 0.5, so we would take 6 and divide it by 12 inches, and that's how we get to the 0.5. So likewise, 3 inches is a quarter of a foot, right? 3 is 1/4 of 12, 3, 6, 9, 12. So 3 inches is 1/4 of a foot, or 0.25. And we'll say 3 inches divided by 12 equals 0.25. Okay? And this chart here, much more simple, very colorful. This is how I kind of visualize this mathematical issue in my mind. So here is 1 inch, 2 inch, 3, 4, 5, all the way down to 11 inches. So in green, this group here, this is these are derivative of 0.25, or quarters, halves and quarters. So 3 is 1/4 of a foot, 6 is 1/2 of a foot, and 9 is 3/4 of a foot. Then I remember these two as being thirds. 4 is 1/3 of a foot, and 8 is 2/3 of a foot. So these are the ones that we use the most. These more odd numbers, they're just not as common, and so they're all based on 0.08. So I probably would pull out I would have a reference. I would have this, on a piece of paper nearby while I was working. I don't have all of these committed to memory. I know they're all based on 0.085. So 7 inches is 1 inch above that. So I would add 0.08 to that and get this. But again, these 5 here are the most common, and that's how I commit them to memory. Okay, so examples: 1 inch equals 0.08. 1 foot 1 equals 1 foot 1 inch equals 1.08 feet. Okay, 5 inches equals 0.41. 6 foot 5 equals 6.41 feet. I'd say 6.14 feet. 6.41. Okay. All right. So when taking quantities, be it figuring out the volume of concrete or talking about a 2x4, we always talk about things in height and depth, width and length. Okay. So depth times width times length. So this board is 2 inches deep here. It is 4 inches wide on the face, and it is 8 feet long. In reality, and so a 2x4 is a nice clear example of that. We also would be, when we do like a concrete, pretend this is a concrete footing for a column. Same thing. We need 3 dimensions to figure out its volume. But in actuality, what you call the length versus the width versus the depth, it's kind of arbitrary. It makes more sense maybe with a 2x4, but otherwise, it's not for figuring out the math. It's not really important which one is which. Some things like windows, they have a particular order. That would be height times width. But in other applications, it's kind of made up, fabricated. It's just a decision that the CM would make. Okay, or the designer. Different ways that the work on a construction project is measured. Okay, so different ways that the work being the components or the tasks at hand on a construction project. So different things we could do to count the sticks and the bricks. We could count the numbered pieces. We measure the length of an item. We measure the area of material, measuring the volume of a material as well as the weight of a material, okay, and liquid capacities. All right, so these are all the different ways that we look at the components in a building to input them into our quantity takeoff, okay? And some examples of them. So counting pieces. counting pieces here. Okay, so that's the top. This is two different ones. Linear feet is the second one. So counting pieces, an example of that would be windows. We count them, 1, 2, 3, 4, 5. There's no real formula to it. If you're building a hotel, there could be formulas involved, of course. And if there's, three windows per unit per room, then you could do some math, obviously. But in general, windows, doors, things like that, sinks would be, plumbing fixtures would be counted. Linear feet. So what is done in linear feet? That would be, so this is looks like a piece of pressure treated wood there. So that could be a sill, the sill plate, for instance, that that comes in contact with the concrete basement, for instance, and that's what and the sill plate is the point of contact for the platform framing for all the wood. So what is the perimeter of the building? How much linear feet of sill plate is needed? Square feet. So this is our two-dimensional look at something. It's not 3 dimensions. We're talking for square feet, we would be determining the square feet of sheathing on the outside of a building, or the square feet of roofing materials, shingles, or the square feet of drywall, for instance. Cubic feet. So now we're into 3 dimensions. So this would be concrete. This is how we will start our project with concrete, calculating volume with 3 dimensions. Okay, so 27 cubic feet equals 1 cubic yard. Okay, so that's what we see right here. This is a cubic yard. So one cubic foot is 1 foot by 1 foot by 1 foot. Okay, so that's a cubic foot of concrete, or a cubic foot of dirt, or those are the big ones. After the concrete, nothing is really coming to mind. So that's 1 cubic foot, and then if we get 27 of those together, we end up with a cubic yard. Okay, and that's what's visualized here, this Rubik's Cube. All right, so when we're ordering concrete, we're going to order it by the cubic yard. So we'll calculate it in square feet, and then we'll divide it by 27, and that'll give us the cubic yards. So it allows us to work with smaller numbers. So if we were working in cubic feet, we'd have too many big numbers, and it was just unwieldy to try to discuss. It's easier to talk about and speak with smaller numbers, basically, and write and calculate things. Gallons. So that would be paint, obviously, or tar for a driveway, for instance, come in gallons. Okay, in addition to these types of numbers, these types of ways of categorizing numbers, there are some other numbers that we will be dealing with when making takeoffs, quantity takeoffs. So we will discuss things in weight as well, pounds or tons. So that could be earth, or steel is calculated ultimately in weight. We will be talking about dollars, of course, the material and labor costs, for instance. We will discuss man and crew hours, so trying to determine how long it takes something to get done. It could just be talked about in man hours or entire crew hours. If we have a crew of 4 carpenters, how many crew hours would it take that group to build a house, for instance? We will have percentages, factors, waste, for instance. So we always add, we expect, like for drywall, for instance, that there will be a lot of waste. So when we get to our final number and figure out how many sheets of drywall we need for the house, we often will add like 10%, because we know that certain materials have a lot of waste. Now, obviously, doors and windows, there's no waste, but other drywall being probably the biggest example, plywood, lumber, concrete. That concrete there could be. They do put numbers in, but I don't think a lot of concrete actually gets wasted. It has to get disposed of. Hopefully not. Productivity factors. So that could be, again, concrete. For instance, if we have 100 cubic yards going in, how the productivity factor could tell us how quickly the crew could do that. And multiplication factors as well. So those are numbers that, like when counting all of the studs, perhaps, that are, counting studs or joists in a floor, we would have a dimension. We would say that we have 100 linear feet of wall, for instance, and how many studs, if there are 16 inches on center, how many studs do we need for 100 feet of wall? And we would use a multiplication factor with that. So the 16 inches into the 100 feet, there are numbers for that to help us with things like that, standard calculations like that. Okay, so that is just the basics to keep in mind while we move into more specific tasks with this exciting subject. All right, thank you.